Welcome to lesson number 3, applications of reference angles and the cast rule. Before we start, we're just going to review what we learned yesterday. We're going to use our knowledge of rotation angles, reference angles, and the cast rule to determine the exact trig ratios for rotation angles from 0 degrees to 360 degrees given a point on the terminal arm. We're going to determine the trig ratios for rotation angle from 0 to 360 degrees given a different trig ratio for the angle. And we're going to solve equations of the form sine theta is equal to A, cosine theta is equal to A, or tan is equal to A, where theta is greater or equal to 0 degrees or less than or equal to 360 degrees. So yesterday we learned about reference angles, and we learned about reference angles in certain quadrants. And so if we have a reference angle in quad 1, the reference angle is going to equal my rotation angle. So as I rotate my my arm around the axis, my reference angle is going to be equal to my rotation angle. As we move over to quadrant 2, our rotation angle is going to equal 180 degrees. Subtract the reference angle. Reference angle would be right there. Quadrant 3, our rotation angle would be equal to 180 degrees plus the reference angle. Reference angle being here. And then in quadrant 4, our rotation angle would equal 360 degrees. Over on this side, subtract the reference angle, which would give us our rotation angle. We can then determine the sign of the trig ratio based on the quadrants it is in. And again, we could use either the cast rule, or we could use a rule add sugar to coffee. In which case, if we're adding sugar to coffee, all ratios will be positive here. Only sine ratios are positive in quadrant 2. Only tan ratios are positive in quadrant 3. And in quadrant 4, only our cosine ratios are positive. Finally, the last thing we need to remember, and what we're going to use in this lesson, are our sine, or all of our trig ratios actually. So sine theta is equal to y over r, cosine theta is equal to x over r, and tan theta is equal to y over x. So let's move on to example number 1. In the previous lesson, we were able to determine the exact values of the trig ratios, given a point on the terminal arm of rotation angle in quadrant 1. In this lesson, we extend the method into quadrants 2 to 4. So this question, class example number 1, tells us that the point P3, negative 3 and 2 lies on the terminal arm of angle theta in standard position. Complete the following procedure to determine the values of the primary trig ratios. So for question A, we're going to sketch the rotation angle on the grid and mark the point P, negative 3 and 2 on the terminal arm. And so if I have a point at negative 3 and 2, I know that I'm going to move negative 3 in this direction, and then 2 in my positive direction on my y-axis. And this is going to represent point P at negative 3 and 2. And we're told that we need to calculate this side of r. And again, I have negative 3 and 2, which means that I have negative 3 in my x and 2 in my y. And so we've done part A, which was simply to sketch the rotation angle on the grid and mark the point negative 3 and 2 on the terminal arm. So part A is done. Let's move to part B. Calculate the exact length of OP equal to r. So O, that stands for the origin, and P, that's just our point negative 3 and 2. So we're actually going from here to here. And we want to know what that exact length of r is going to be. So we know that OP squared is going to be equal to our x squared plus y squared. In this situation, OP is equal to r. So if I have OP squared, that's going to equal negative 3 squared plus 2 squared. and that's going to equal 13. So OP is going to equal rad 13. And we can leave it as a radical, just like we would have done in the last unit. So moving on to question C. Use x equal to -3, y equal to 2, and r from above to write the three trig ratios for angle theta. So if I'm starting with my sine ratio, sine theta is equal to y over r, or 2 over root 13. Remember we had root 13 was equal to r, or in this case OP. I'm just going to also say it's equal to r, just to make things easier for us in the future. And remember from last unit, if we wanted to rationalize our denominator, we would have to multiply it by the conjugate, or in this case, we're just going to rationalize it. So I'll multiply that by rad 13 and that by rad 13, in which case we'll be left with 2 rad 13 divided by 13. Moving on to our cosine ratio, cosine theta is equal to x over r, which is equal to -3 over rad 13. Or again, if we rationalize it, I'll have -3 rad 13 over 13. And then finally, our tan ratio, tan theta is equal to y over x, which is equal to 2 divided by -3. And we can leave it as this, or just -2 over 3. And there we have all three of our trig ratios in terms of x, y, and r. Next question, I have the point -4 and -2, which lies on the terminal arm of angle theta in standard position. Determine the exact value of sine theta. So I'm just going to highlight the information that I have. I know that I have the point -4 and 2. So the first thing I'm going to do, I'm going to start by just drawing my x and y axis and placing my given data points on my x and y axis. In doing so, if I go -4 and 2 over this way, my point is going to lie somewhere in quadrant 3. And so the next thing I need to do is determine the exact value of sine theta. And so once I put in all my information, and I'll be knowing what I'm looking for. And so I know that I have my x value, which is equal to -4. I have my y value, which is equal to -2. And I also know that in order to find my r value, I need to use my Pythagorean theorem. R squared is equal to x squared plus y squared. X squared would be equal to -4 squared plus -2 squared. R squared would equal to 20. So remember, we need to take the square root of both these to get simply my r value. So r will be equal to rad 20. If I simplify this, this will be equal to rad 4 times 5, or 2 rad 5. So now I know what my r value is. I can find out what my sine ratio is, because remember, we want to determine the exact value of sine theta. So I'll plug it into sine theta is equal to y over r, which is equal to my y value being -2, and my r value being 2 root 5. If I simplify this, I know that I can factor both of these by 1, or sorry, by 2, which would leave me with -1 over root 5, since 2 goes into -2 and 2 once. And so I'm left with -1 over rad 5, and if I rationalize this, I'll be left with -5 over 5. Let me write this better. This will be -5 over 5. For this next question, angle A terminates in the third quadrant with sine A is equal to -4 over 5. Complete the following procedure to determine the values of cos A and tan A. Since sine A is equal to -4, over 5, which is equal to y over r, we know that the point x and negative 4 exists on our graph and it lies on the terminal arm in the third quadrant with r equal to 5. Sketch a diagram and draw the reference triangle and mark x, y equal negative 4 and r equal negative 5, positive 5 on the reference triangle. So just like our last question, the first thing we're going to do is begin by making my 4 quadrants. And right away I know where I have some information. Okay, so I know that we're going to be using our third quadrant because we want to find out the values of cos A and tan A, but we also know that we have a negative sign value in our question. And so we know it can't be in the first 2 quadrants because I don't have a positive sign ratio. It's a negative sign ratio. Remember, if we add sugar to coffee, all ratios are positive here. Only sign ratios are positive in this quadrant. And in the third quadrant, I'm adding sugar to coffee, so I only have my tangent and my cosine ratios, which can be positive. And so we're going to end up in our third quadrant down here. And so if I were to draw my angle, I know that since I have my y and my r values, 4 and 5, I know that I'm going to have a y value of negative 4. I'm not sure what my x value is, so I'll leave that as x. And then I have my r value equal to 5. And finally I know that that's a standard angle, so it's going around my origin counterclockwise. Next thing we need to do is use x squared plus y squared equal r squared to determine the value of x. Note that in quadrant 3 the value of x must be negative. Okay, so we're going to use the Pythagorean theorem here in order to find my value of x. And so if I use x squared plus r squared, let's just fill in what we have. X squared plus y squared is equal to r squared. So I don't know what x squared is, but I do know what y squared is. This was negative 4, which I found out in the beginning. And I also have r squared, which is going to be 5 squared. Next thing we can do is just solve this out. X squared plus 16 is equal to 25. If I rearrange my equation, I'll have x squared equal to 9 since I subtracted 16 from both sides. I'm left with 9. And that gives me x squared, so I need to take the square root of x squared, which would leave me with x, and x is equal to 3. But remember, in quadrant 3, the value of x must be negative, so I know that I'm going to have negative 3. And that will be my final answer. For part C, let's use the value of x, y, and r to determine the exact values of cosine A and tan A. So let's begin with cosine A. If I have cosine A, I know that that is equal to x divided by r, which is equal to negative 3 divided by 5. And we can just leave it like that. And then for tan A, we need to find the exact value as well. Tan A is y over x, which is equal to negative 4 over negative 3. Negative and a negative, we'll just split the positive, 4/3. So these are our exact values for our sine ratio, for our cosine and tangent ratios. Next, we're going to use reference angles and sines of the trig ratios to solve different equations in sine theta, cos theta, and tan theta. So in order to do so, we need to determine the quadrant the angle will be in by looking at the sign of the ratio. And so depending on if it's positive or negative, we'll know if it's in either quadrant 1, 2, 3, or 4. And then once we do that, we'll determine the reference angle by plugging it into our calculator and using the second function of either sine, cosine, or tan. And then we can determine what the rotation angle is based on the reference angle and the quadrant that it is in. So let's look at this class example number 5. So use the procedure above to solve sine theta is equal to 0.5, where theta is greater than 0 and less than 360 degrees. So let's start by drawing our 4 quadrants. And if we follow our rule, add sugar to coffee, or our cast rule, we know where each trig ratio is positive or negative. And so since we're using a sign ratio and we're given our value, we know that it's positive. So we know that it has to be either in quadrant 1 or in quadrant 2, because sign ratios are only positive in 1 and 2. The next thing we're going to do is use our calculator. So in my calculator, I'm going to type second function, sine, or inverse sine, and I'm going to type in 0.5. And I'm given a reference angle of 30. My reference angle is equal to 30 degrees, which means that I have 30 degrees here, and this is also 30 degrees, which means that in quad 1, remember that your reference angle is equal to your rotation angle. So I could say that I have one angle of theta that is 30 degrees, and then my second reference angle, if I subtract my reference angle from 180 degrees, that'll give me my second reference angle. And so that says that 180 degrees minus 30 degrees will be equal to my other value of theta in my quadrant 2, which means that that is 150 degrees. Therefore, theta is equal to 30 degrees and 150 degrees. All right, let's skip down to these examples on the bottom. Find the measure of x to the nearest degree where x is greater or equal to 0 degrees or less than or equal to 360 degrees. So the first thing we're going to do is start by drawing our quadrants, and remember that we add sugar to coffee or cast. And this is going to tell me where all my ratios, again, are positive or negative. And so we look at the sign in front of our ratio of 0.809, and we determine that, okay, since it's negative, remember that your sign values are positive in the 2 first quadrants, which means that since it's a negative value, my sign ratio will be down here. So the first thing I'm going to do is I'm going to type in this value in my calculator. I'm going to go inverse sine of 0.809, and I get a value of 53.99. That's my angle. I'm just going to round that up to 54 degrees. Again, that's going to be my reference angle. So I know that my reference angle is equal to 54 degrees. So that's 54, and that is also 54. Now we need to find out what my actual angles of rotation are. Okay, so for my first angle of rotation down here, starting from my standard position, I'm going to have my theta is equal to 180 plus 54. In my third quadrant, I know that it's going to be 180 degrees plus 54 degrees, which would give me 234 degrees. And then my second angle, since it's in my fourth quadrant, will be 360 degrees, subtract 54. So 360 degrees, subtract 54 degrees, and you'll get a value of 306 degrees. So my two values of theta are going to be 234 and 306. So for my cosine of x equal to negative 0.8090, again, I know that my value of my ratio is negative, and so that's going to give me an indication of which quadrant that this is going to exist in. Since I know that I add sugar to coffee, my cosine ratios are positive in my first and fourth quads, which means that this particular question is going to take place in my my second and third quads. So my angles are going to look something like this. It's going to take place in quadrant 2 and quadrant 3. And so we are going to begin by, again, typing this into our calculator with our inverse sine, 0.809. And again, I get an angle, a reference angle of 54. Oh, it's because I use my inverse sine. I want to use inverse cosine. 0.809 is 36 degrees. So that's the angle we're going to use, 36 degrees. And again, that's our reference angle, which is equal to 36 degrees. And we're going to do the exact same process that tells us what our reference angles are. Those were 36 degrees. And we can now find out what our angles of rotation are for both of these questions. And so my first angle of rotation is going to be 180 degrees. I'm using this one here. 180 degrees, subtract 36, which will give me 144 degrees. And then my second one will be 180 degrees plus 36, which will give us 216 degrees. Now let's move on to this last example on this page. The tan x of negative 2.4586. Okay, so we have a negative tan value. So let's find out where this guy's going to be. And if we add sugar to coffee, we know that the tan ratio is negative in my second quadrant and also in my fourth quadrant. So if you're still confused with how we know that, is by our cast rule or our sugar rule, add sugar to coffee or cast. I know that tan is only positive in these two. And so if it's a negative value, it must be in either quadrant 2 or quadrant 4. Now let's find out what this ratio is going to be. So we plug it into our calculator. Inverse tan of 2.4586. I have a reference angle of 67.8, but I'm going to round that up to 68 degrees. So my reference angle is 68 degrees. And I'm looking for my values of theta, which would be here and here. And so let's solve this first one. Right here is going to be 180 subtract 68, which would give me 112 degrees. And then my second value of theta will be 360 degrees subtract 68, which would be 192 degrees. And that's how you do class example number 6. Let's look at class example number 7 now. These next two questions they might look a little confusing when you at first look at them, but if we look at sine theta equal to 1 and cosine theta equal to 0, both these questions are a type of question called a quadrantal. And the reason is because they're both going to have just one answer. Now if we type in inverse sine of 1, we get 90 degrees. And that tells us that we have one angle going straight up at 90 degrees. And so it can be 90 degrees on both sides since that gives us the reference angle, but there's only one angle. And so there's only one answer of 90 degrees. And same thing if we do the inverse cosine of 0, again we get 90 degrees, which tells us that we have 90 degrees here, and simply 90 degrees. Okay, final question in the class example number 8. Solve the equation 3 tan theta plus 1 is equal to 4, where theta must be greater or equal to 0 degrees, or less than or equal to 180 degrees. So for this question, we really need to pay attention to this. This theta is greater or equal to 0, or less than or equal to 180. Because before we've been solving questions where theta is greater or equal to 0, and then less than or equal to 360 degrees. So immediately we know that we're going to be working in quadrants 1 and 2. Since if I draw a quadrant and I have 0 degrees, 90, 180, 270, and 360 degrees, I know that 0 to 180 degrees only covers quads 1 and 2. Okay, so we can ignore this whole bottom part of our graph. So before we start and find out where this is going to be, we have to solve this part of the equation as well. And that was 3 tan theta is equal to plus 1 is equal to 4. So this is just an algebraic equation we can solve by taking away 1 from both sides. So let's start out with 3 tan theta plus 1 is equal to 4. If I subtract 1 from both sides, I'm going to be left with 3 tan theta is equal to 3. And then I'm going to divide by 3 in order to get rid of this 3 and isolate this tan theta. So divide both sides by 3. And we have the tan theta is equal to 1. Now when we type this into our calculators, I'll have tan theta of 1, and I get 45 degrees as my reference angle. So the reference of theta is going to be 45 degrees. And again, let's look at what that means. If we have a reference angle of 45 degrees, I also have a value of theta for 45 degrees, which would be our final answer.